Hi everyone. So in this video we want also solve another problem that is related to hyperbola. Now here is also asking us to rewrite this general form of hyperbola into its standard form, and then we should also find the same thing we found in the previous video. You may like to also see that video. Right, so here what do we do? Just the same process. So I am going to write my 4x squared, and then I'll bring the x to it, and then the next is my minus 9y squared, and then I'll bring the 54y. In this case there's another term for y, and then I will take the constant to the other side, and that will give me 101. So what do I do here next? So I am going to make the coefficient of the x and y to be 1 by factorizing. So I have 4 here, I bring it out, then that will give me x squared plus 4x, and then I close the bracket, minus, in this case you have 9, and that will give you y squared, minus also, because minus times, when you use this minus to multiply what is inside, it will then give you this plus. So it's supposed to be minus, and so this is going to be minus, and that is equal to 101. Right, so we are going to now perform the completing square on the two brackets, because here we have the two of them. In my previous example it was just on x. So if we do that, and to perform that, you need to add the square of the half of the coefficient of x to both sides. You also do that for this other one. And so to be able to do that, I am going to add for the first bracket, the half of 4 is 2. So I'm going to add 2 squared, and that's going to give me 4 actually. So that means here is going to be 4 into the bracket of x squared plus 4x, plus, now here you are going to have 2 squared. I usually would say let's leave it as 2 squared, which is 4, and then that will be minus 9 into the bracket of y squared minus 6y. Now the half of minus 6 is minus 3, so when you square it, it will be this way, which is and you are adding to both sides, that minus 3 squared. Okay, you close the bracket now, and that is equal to, now recall like what we did in the previous example, you are adding this to the both sides. Now that means you need to also add the same thing you have added on the left hand side to the right hand side. But also remember, like we did in that example, if you are adding this to this side, it's not exactly this 4 that will add here. Why? Because by the time I open this bracket, the 4 outside the bracket is going to affect the value of this 4 inside. So it's assumed that the total value of what you have inside here is going to be multiplied by this 4. So this is actually 16 and not just 4. So it is that 16 that I will add here, and then plus on this other bracket, you can also see here, by the time you square minus 3, you will have 9. But this 9 will also be affected by the 9 outside the bracket. And by the time the 9 outside the bracket multiplies, that's going to be negative 81. Okay, so you are adding negative 81 to the other side of the equation, and that's going to give us minus 81. All right, so what is that going to be? So we're now going to now collect the, form the perfect squares inside the brackets. So here is going to be 4 into the bracket of x. So I'm doing that by joining the squares inside each of the brackets. Okay, so here is going to be x plus 2, then all squared, and that is minus 9 into the bracket of, I will join the squares also, y, and then negative 3. Okay, so you have negative 3 all squared, which is now equal to, we're going to have on the right hand side 36. Okay, so, and then what do we do next? We make that right hand side to be 1. It needs to be 1 because in the equation of a hyperbola, the right hand side is always 1. So I'm going to divide through by that 36. So by the time you divide here by 36, we are now going to obtain, of course, 4 will go into this to give us 9. So that will give us x plus 2 all squared, then all over 9 minus 9 will cancel this to give us 4. So we'll have is equal to 1. All right, so and this is the solution, which is the standard form of the hyperbola equation that was given to us, which is this originally. Okay, so from here now we need to now look for the center, look for the a and b, and then the focus. So let's quickly do that. So for a, the center of this particular equation is simply the negative of the whole of this. So if I take the negative of minus 2, sorry, of 2, I will get minus 2, comma. If I take the negative of this, I will get positive 3, and that is my center. And then what about B? For your A and your B, your A is the square root of the denominator of x, and the denominator of, the square root of 9 is 3, and the square root of B, which is the value of your b, which is the square root of the denominator of y, and that will give us 2. And finally, for the foci, we need to get the value of our c. Our c is the square root of a squared, which is 9, plus the square root of b squared, which is 4. That's going to give us the square root of 13. Therefore, it means that the foci, which is equal to plus or minus c comma 0, is just equal to plus or negative root 13 then comma 0, and that is the foci for, or the coordinate of the foci for this particular hyperbola. And of course, that is all I have for you. So in each of these, you should just be aware that you need the completing square method from your quadratic equation to be able to rewrite from the general form to the standard form of either the hyperbola, the circle, or even the ellipse, as we have seen previously. We'll see you in our next video. Kindly subscribe to our YouTube channel. Do give us a thumbs up and then share this video also. Bye.